Hello guys, welcoming you all. Today we are going to see about review of elementary quantum physics in laser and optics. Elementary quantum physics. Elementary quantum physics refers to the basic principles and concepts of quantum mechanics, which is the branch of physics that describes the behavior of particles at atomic and subatomic scales. Several sectors of quantum mechanics: quantization of physical properties, wave particle duality, uncertainty principle, quantum states and superposition, quantum entanglement, quantum tunneling. Quantization of physical properties. Quantization is the concept that a physical quantity can have only discrete value. Electrical charge, energy, light, angular momentum, and matter are all quantized on the macroscopic level. They do not seem quantized on macroscopic scale because the size of the steps between each possible values is so small. The diagram shows that original signal, quantized signal, and quantization noise with respect to time. Wave particle. The concept that wave particles like electrons and photons exhibits both wave like and particle like properties. It expresses the inability of classical concepts of particle or wave to fully describe the behavior of quantum scale objects. According to wave particle theory, light has the property of both wave and particle. Wave particle duality refers to the fundamental property of matter, where at one moment it appears like a wave and yet at another moment it acts like a particle. The diagram shows that amplitude and wavelength with respect to time. Uncertainty principle. It is formulated by Werner Heisenberg. This principle says that it is impossible to measure or calculate exactly both the position and momentum of an object. This principle is based on the wave particle duality of matter, although Heisenberg's uncertainty principle can be ignored in the macroscopic world. It holds significant value in the quantum world since atoms and subatomic particles have very small masses. Any increase in the accuracy of their positions will be accompanied by an increase in the uncertainty associated with their velocities. Diagram shows that del x into del p is greater than or equal to h divided by 4 pi. Del x change in electron's position, del p change in electron's momentum. H is equal to Planck's constant. Quantum state and superposition. Superposition is the ability of quantum system to be in multiple states at the same time until it is measured. The most general state is a combination of all of these possibilities where the amount in each configuration is specified by a complex number. One example of superposition is the double slit experiment, where two slits in a barrier allow for a passage of electrons. The results of this electron or experiment is an interference pattern not predicted by classical mechanics. Quantum state and superposition. Diagram shows here. Quantum entanglement. Quantum entanglement is a physical phenomenon that occurs when pairs or groups of particles are generated or interact in ways such that quantum state of particle cannot be described independently of others, even when the particles are separated by a large distance. Instead, a quantum state must be described for a system as a whole. Diagram shows that laser beam enters to the crystal. Quantum tunneling. Quantum tunneling is defined as a quantum mechanical process where wave function or particle can penetrate through a potential barrier. The transmission through the potential barrier can be finite and relies exponentially on the barrier width and barrier height. Elementary quantum physics forms the basis for many advanced topics in quantum mechanics and has profound implication for our understanding of the behavior of matter and energy at smallest scales of nature. Thank you.